Hello everyone, welcome to my YouTube channel. Today's lesson is about infrared spectroscopy. Infrared spectroscopy is a technique or spectroscopic technique used to structural elucidation or identification of organic compound by their functional group. Now, the rule or different rules to characterize the infrared spectroscopy of a given organic compound. The following rule must be considered to characterize or to identify the functional group of organic compound using our instrument. The first one is by using the molecular formula of the compound, calculate the index of hydrogen deficiency or degree of unsaturation. The degree of unsaturation or index of hydrogen deficiency is helpful to calculate the number of double bond or the number of cycle. To know the number of cycle or to know the number of double bond present in the compound, we can easily know that to analyze the IR or the functional group of a given compound. And the next one is we examine the hydroxide region. It means we can easily put your eye on the region around 3200 to 3400 to identify the presence of hydroxyl group or OH group. If the OH group is narrow peak, it is maybe the OH of the alcohol, or it may be highly broad, it may be the OH of the carboxylic acid. Also, the OH of carboxylic acid and the OH of the alcohol can be identified by the index of hydrogen, because the carboxylic acid containing one hydrogen index of hydrogen deficiency, but the OH is 0. The other case, in the carbon spectra, the IR spectra, there is a peak, a sharp peak around 1700 to 16500 for carbon double bond oxygen of carboxylic acid. So we can easily identify the OH of carboxylic acid and the OH of alcohol. The third step is then we have looked at the carbonyl region from about 16500 to 1830 centimeter river for sharp strong peak toward typicals of carbon double oxygen group. Here we want to quickly know if there are any carbon double bond oxygen group present in the compound. The first one is using this three piece of information, we could then rule out various options that we can given to us, narrowing down the possible option. And granted this, we are relatively simple example, only carbon, hydrogen, and oxygen. But those process is what's important. This rule may be guided to that we can rule out within a given choice of a compound, we can easily identify the carbonyl group, the OH group, and the index of hydrogen deficiency. Let's take one example as a tip. Look this one. Which of the following is best correspond to their spectrum below? The first one is cyclohexanol, there is ether, there is ester, ketone, and there is also alcohol. Now look the spectra. The spectra is the molecular formula of C6, the compound one is C6H12O. Now, the index of hydrogen deficiency is calculated as 6 times 2 plus 2, it is 40, minus the number of hydrogen 1, 2 divided by 2 is equal to 1. This indicates that the compound at least is containing one double bond or one cycle. Let's check one by one. Let's say choice A. Choice A indicates the presence of one OH. Now there is a peak around 3300, but the peak is very low peak. So this is maybe not for the OH of this one. The other case, there is no a peak around carbon double bond oxygen for this one, for this choice. So A is immediately ruled out. Now B, similarly, there is no carbon double bond oxygen peak for this compound. It is ether, so there is a peak around 1100 carbon single bond oxygen, but there is no peak for this one, for carbon double bond oxygen, so B also ruled out. What about C? Now C containing ester bond, so there is containing carbon double bond oxygen, but the compound containing the index of hydrogen deficiency is 2, because there is one carbon double bond and there is also a cycle, so C is ruled out. Now D, there is no OH peak, because now in this case the OH peak is broad, but this one is not for OH peak. It may be some moisture or some peak spike is observed, but this is not the peak, broad peak for OH at 63300. Now, the OH index of hydrogen deficiency for D is 1. There is also carbon double bond oxygen peak around 1700, so D is satisfied the spectra. The other one is E. There is OH, so this OH or around 3300 is not the OH because very sharp, not a very broad peak. Other one is there is no carbon double bond oxygen at 17004 E. So this also ruled out. So by this case, the exact answer is D, because D satisfied the higher spectra of the compound. Thank you for your attention, and please don't forget to subscribe, share, and comment. So to further work, you can subscribe the channel. Thank you for your attention.